Hi everyone, I wanted to take a few minutes to go over this lab with you. So this lab will be over VSEPR theory, VSEPR, which stands for Valence Shell Electron Pair Repulsion Theory. And what this is basically a tool that allows you to estimate the shape of a molecule in 3D space. Okay, since we know that things like electrons are negatively charged, and we know that those like charges will push away from each other, this gives us a way to sort of visualize and estimate the actual shape of a molecule in 3D space. So you'll find a folder for this lab, as always, and you'll find a few things here. So you'll find, firstly, the experiment sheet, which will give you the background and the instructions, of course, the report sheet, which you'll turn in. I've added this video for you over VSEPR theory, and this will just give you a basic overview of VSEPR theory. Hopefully you've covered this in your lecture, and this will basically be review. If not, and you have any questions, please do let me know on that. But he does a good job, and this is why I always link his videos, because I think he just does an excellent job, and it's very visual. So I think that will sort of help you along. And then down below that, you will find a simulator, which will help you with the second section of the lab. Then, of course, you'll find a place to turn in the assignment, which I haven't quite edited just yet. Okay, so let's take a look at what it is you're doing. So this one is a little more involved. So normally we've been doing things that just involve paper or your computer, but this one is actually going to ask you to work with your hands a little bit. So we're going to start moving gradually into labs as you start to get your lab kits, of course, and we're going to start to learn labs that move more into the hands-on part. So this one, if you don't have your lab kit, that's still okay. We don't need anything from the lab kit for this one, but we are going to get a little bit more hands-on with this one. Okay, so the first thing is Lewis structures. So I will also post a video of mine that goes over in detail drawing Lewis structures that I think you'll find helpful if you've never done it before. Okay, so that'll be your first section. And then we'll get into your actual experiment. So Lewis structures and VSEPR structures are very, very similar. The main difference being that the VSEPR structure takes account for the electron repulsion and actually puts it into 3D space. Okay, where your Lewis structure is only in a 2 dimensions, essentially. Okay, so for the first part, you're going to be looking at, basically you're going to make sort of a modeling dough or clay, and you're going to use that along with some toothpicks to actually sort of visualize and build models of molecules. Okay, so it says you can also substitute Play-Doh here. So modeling clay, Play-Doh, if you already have these on hand. They give you a recipe at the end to make this modeling dough. We also have this simulator, which will essentially do a lot of the same things. And the biggest advantage over actually doing this out of the clay is that you actually can hold it and spin it around and actually look at it in 3D space. But you do have this simulator, which is also an option for you, where if you just click on the atoms like this, it will go ahead and put them into the right positions for you. So you can also add things like lone pairs. Okay, so that'll give you an idea as well. But I really think just for your own learning capability, I think building the model will really, really help, and it'll help solidify this VSEPR concept. But if for some reason you can't do that, you're also welcome to use the model. Okay, so it's going to kind of guide you through how to work with the clay or your dough. It's going to ask you to do certain things. Okay, so it says you make a smooth ball, make 6 smaller balls, and it's going to ask you to do things like place 2 toothpicks as far apart as possible. Okay, then draw the structure. And it's going to ask you for the shape or geometry of what you formed. Okay, so what's good about this is it will give you a chance to actually hold it and figure out what is the furthest apart. Okay, and then look at what shape it is and see it in complete 3D space since you're actually holding it. You can turn it however you want and see from a lot of different angles. And as you move through the experiment, that will become more and more handy. Okay, whereas with the model, really you just have it sort of on your screen, and it's not quite as interactive, and you don't get quite the same experience there. Okay, and then with the simulator, they're going to give you some instructions here. So it wants us to go Okay, so with the second part, it wants you to go to the simulator, and it wants you to go to this real molecules. And in your report sheet, there's going to be some that it asks you to make here. So it says molecular shape simulation table. So these are the ones that it wants you to do with the simulator. And you'll see that up in the right-hand corner here, you have the option to select a bunch of different molecules and take a look at their shapes. Okay, so first part will be from your modeling clay or dough, and it'll just ask you to add number of toothpicks, draw the model. This would probably be a good one to print out if you have the capability, or run to Kinko's or something like that, since it is going to ask you to draw these. So ask you to draw a diagram, give approximate angles, give the electron pair geometry. So that's the geometry only accounting for how many electron domains there are, meaning anywhere there's a double bond, single bond, triple bond, or lone pair, that's going to be part of your electron geometry. And then your actual molecular shape deals just with the bonding. Okay. And you can find these in tables. I can even maybe post a link to a table that has all of the geometries listed for you. Okay, so that'll be your first section. And then the second section, they want you to go to that simulator, build these molecules, and do a lot of the same things. So number of valence electrons, which you'll just count up. Lewis structure, so they're going to ask you to draw the Lewis structure. Give the angles from the simulator and the molecular geometry from the simulator. Okay, and going back to your experiment sheet here, you'll see the recipe for the modeling dough, and you will also see the instructions on how to make it. Okay. So if you have any trouble with this, do let me know or come see me. Otherwise, good luck.